This is the Chapter 8 Part 5 video. In this video, we're going to talk about the E1 and E2 elimination reactions. So before we jump into that, let's quickly review the differences between substitution and elimination. You can see up here a substitution reaction where, of course, the nucleophile is going to displace the leaving group. And in the elimination reaction, we have the same situation where we have a leaving group. We also have an electron-rich portion, but in the elimination reaction, it's going to act as a base and deprotonate a beta hydrogen, that hydrogen shown in green here. And when it does that, it is going to kick out the leaving group and form the double bond. So that's the difference between the two reactions. Notice that that beta hydrogen is very critical and must be present for elimination to occur. If it's not there, then you can't have an elimination reaction. So there are two types of elimination reactions. You've already seen the E2 reaction. In the E2 reaction, the elimination happens all at once. This is very similar to the SN2 reaction, where the base is going to come in and pull off that hydrogen and then kick off the leaving group all at once. So if we were to draw an arrow from the base, right, it's going to go to that hydrogen, and then the electrons come down and kick off the leaving group. And that is all going to happen all at once, resulting in the double bond shown over here. In the E1 reaction, you'll notice that it is very similar to the SN1 in that we're going to have this carbocation intermediate here. You can see the arrows drawn in here. In E1, the 1, of course, stands for unimolecular, right? Where in E2, the 2 stands for bimolecular. Unimolecular meaning that only one substrate is involved. And so you'll see that the leaving group falls off first, right? Whereas in the E2 reaction, where it's bimolecular, both the base and the substrate are involved. So in the E1 reaction, the leaving group falls off first, resulting in the carbocation intermediate. So far it's just like the SN1 reaction. And then the base comes in, pulls off the beta hydrogen, and the electrons come down to form the double bond. So this is our alkene, our resulting alkene over here. And this is our resulting acid. So you can see between the two reactions, the key difference being the intermediate, E1 taking place over 2 steps and forming a carbocation intermediate, and the E2 reaction happening all at once with no intermediate, a one-step reaction. Okay, so let's check out the reaction coordinate diagram for an E1 reaction. As I mentioned, it is a 2-step reaction, and so you can see that here in this reaction coordinate. Here are the reactants on the left. The leaving group falls off first, and that creates a carbocation intermediate. So this is our intermediate here. And then you can see over here the products of the reaction. So we'll notice a couple important things with this. As with the SN1, you'll notice that this first hump is higher than the second hump. So this is going to be our rate limiting step, or our slow step for the reaction. Okay, and the second step is downhill, and this is going to be pretty well favored. So we can see in this picture, again, that heterolytic cleavage, that first step, is going to be rate limiting. So you can see this is our delta G double dagger. This is the highest point in the reaction coordinate diagram, known as the rate limiting step. So this is going to be the slow step in that part of the reaction, and this is the rate limiting step for both the SN1 and the E1 reactions.